Welcome to my channel Simple Concepts by TJ. In this we are going to discuss about another problem which comes under the application of integration. The question is the equation of the ellipse will be handed over to you. Equation of ellipse is x squared by a squared plus y squared by b squared equal to 1. This is the equation of the ellipse, and you will be asked to find the area that has been enclosed by this ellipse. You need to find the area that has been enclosed by the ellipse, which is having an equation x squared by a squared plus y squared by b squared equal to 1. Okay, this is the question. Okay, so now what we need to do is, I'll write the question over here. We are supposed to find the area enclosed by the given ellipse, by the given ellipse. So they have given the equation of ellipse, that is x squared divided by a squared plus y squared divided by b squared equal to 1. So first is that I'm going to draw an ellipse that has been fixed at the origin of the axis. The center point of the ellipse will coincide with the origin. So this is the axis. This point is origin. The coordinate is 0, 0, and this is a point A, and the coordinate of A will be A, 0. Similarly, the coordinate, this point B will be 0, B. The ellipse which I am drawing will pass through the point B and A and B will pass. So I am drawing the ellipse over here. This is the ellipse. So now this is the ellipse, and they have given the equation of the ellipse as x squared by a squared plus y squared by b squared equal to 1. So now what I'm going to do is that I'm going to consider a vertical strip, just, okay, vertical strip which looks like a rectangle. The length of the vertical strip will be y, and the breadth of this vertical strip will be dx, right? Will be dx. This vertical strip looks like a rectangle, therefore the area of the rectangle, will be length into breadth. Similarly, for this vertical strip, the area will be y into dx, right? So what I'm going to do is area of the strip, area of the strip means this vertical strip, okay, will be y into dx. It will be y into dx because it looks like a rectangle and the area will be length into breadth. Here the case is y into dx, right? So now I am interested to find the region, the area of this region enclosed by the quarter of the ellipse. A quarter portion of the ellipse has occupied this area, that is OABO. So first I just wanted to know what is the area that is lying in the first quadrant of this graph. So what I'm going to do is I'm interested to find the area of the portion area of the portion OABO. OABO. This is the area I'm interested to find. So what I'm going to do is, while finding this, since it's going to be the entire quadrant, I can find this area by integrating the area of the vertical strip by fixing the limits. So the area of the portion OABO will be integral tends from 0 to a, and it will be y into dx. Because I just wanted to know the entire area, in order to find the entire area, I am integrating it along with the limits. So if I do it, I'll be able to get the area that has been covered, or area that has been included in quadrant number 1. Okay, so this is 0 to a integral y into dx. But before proceeding into the problem, I just wanted to know what is the value of y. So for me, the equation of the ellipse is given. So from this equation, I can derive the value of y. So for deriving the value of y, what am I supposed to do is, see, this is the equation of the ellipse, x squared plus by a squared plus y squared by b squared equal to 1. So I just wanted to know what is the value of y. So from this equation, I can derive the value of y. So it will be y squared divided by b squared equal to 1 minus x squared by a squared. Right. So I'm going to simplify this term 1 minus x squared by a squared. I'm going to simplify now. So if I simplify it, it will be a squared minus x squared. So y squared will be b squared divided by a squared into a squared minus x squared. So y squared. So I just wanted to know the value of y. So if I want to know the value of y, y will be plus or minus root of b squared divided by a squared into a squared minus x squared. Right? So the whole term, the whole expression, I am bringing it under square root, putting both the signs positive and negative. Since now in the first quadrant, all my values will be positive. When compared to the other 3 quadrants, my first quadrant, all the quantities, if I work in quadrant number 1, will be positive. So here also I am going to take the positive value of y. So I am going to truncate the negative value of this expression. So what will be now is, it is positive value. So root of b squared by a squared will be b by a. So it will be b divided by a into root of a squared minus x squared. This is the value of y. Therefore, y, from the equation of ellipse, I found it to be b divided by a into root of a squared minus x squared. This a squared minus x squared portion will be under the square root. This b squared by a squared under the square root, if I take outside, will be b by a. So from this, I have derived the value of y. So now what I'm going to do is that, with the value of y which I had just now got, I'm going to substitute the value of y in the integral value. So I'm just erasing this part, okay, with just the y value. So what will happen is, my next step will be 0 to a. This y value I have obtained, it will be b divided by a into root of a squared minus x squared into dx. It will be from 0 to a. This is 0. It will be from 0 to a, b by a into root of a squared minus x squared into dx. So I have received the y value and I have substituted it inside the integral, which is being guided by a limit. So now there is a formula for this one, that is integral root of a squared minus x squared, which is nothing but x divided by 2 into root of a squared minus x squared plus a squared divided by 2 into sine inverse of x by a plus c. So this, I have a formula. This is an integration formula. Now I am going to substitute these values in this formula, and with that I'll be able to get the equation, get the value for the area that has been bounded by the ellipse in quadrant number 1. Okay, so what I'm going to do is, this I am taking it over here, so it will be b by a, I am bringing it outside. Similarly, integral of root of a squared minus x squared into dx will be there. For that I am using this formula. The formula will be x by 2 into root of a squared minus x squared plus a squared divided by 2 into sine inverse of x by a plus c. Plus c. Now I am going to fix the limits, that is from 0 to a. 0 to a, I am going to fix it in the result, which in the formula which I had derived. So I have fixed the limits over here. So now what will happen is, here I am going to write it over here due to insufficient space. So this will be b by a. This will be b by a. Now I am going to substitute the value of a in terms of x. So it will be a by 2, a divided by 2 into root of a squared minus x squared into root of a squared minus x squared will be a squared minus a squared. So a squared minus a squared plus a squared by 2, a squared divided by 2 into sine inverse of x. I am going to substitute with a. So sine inverse of a by a plus c. Okay, for the first expression, instead of a, I have substituted with a. Instead of x, I have substituted with a. So it will be a by 2 into root of a squared minus a squared plus a squared by 2 into sine inverse of a by a plus c. So in the second term, what will happen is, instead of x, in place of x, I'm going to substitute 0. If I substitute 0, 0 by 2 is nothing but infinity. So this will become void. Again, x by a, 0 by a is again infinity. So this also portion also will be void. So substitution with 0, based with 0, or substituting with 0 in x term cannot be done over here, because you will get infinity values. So I am truncating that. Okay, so what will happen now? Here, this is the only expression which we had obtained. So now, which is equal to b divided by a. So what is a squared minus a squared? It is 0. Therefore, this portion also will become null and void. So only I am left out only with this expression, which is nothing but a squared by 2 into sine inverse of a by a. Sine inverse of a by a will be 1. Sine inverse of 1 is nothing but pi by 2, because sine 90 degree is 1. Sine inverse of 1 is pi by 2, which is pi divided by 2. Pi divided by 2. Therefore, here a gets cancelled. So I'll be left out with pi AB pi into A into B divided by 4. So this is the area value for the area in quadrant number 1. So now I have 4 different type of quadrants over here. So this is 1, this is 2, this is 3 and this is 4. So for getting the entire area that has been bounded by the ellipse, what I'm going to do is that I'm going to multiply by 4. If I happen to multiply by 4, 4 and 4 will get cancelled. So I'll be left out with pi AB. Pi AB. This is the final result and this is nothing but the area that has been enclosed by the ellipse, which is having its center point at origin, having origin 0, 0, right? So the value, the final result is pi AB, fine. So this equation, for I have found the area enclosed by the ellipse having the vertical strip. Now I am going to do the same operation by having the strip in the horizontal direction. So if I do the vertical strip, I got pi AB is my final answer. So even if I take a horizontal strip and if I work out the area, the same result I will be getting it. So now what I'm going to do is that I'm going to use a horizontal strip instead of a vertical strip. So what I'm going to do is I'm rubbing the entire thing. So this is the area enclosed by the ellipse, everything remains the same. Okay, so now what I'm going to do is instead of using the vertical strip, I'm interested to find the area by using a horizontal strip. See, this is the ellipse, right? This is the ellipse. This is the ellipse, outer part of the ellipse. Now I am introducing a horizontal strip. A horizontal strip such that the length of the horizontal strip is nothing but x, and I am naming the breadth of the horizontal strip as y. So in the previous case we did with y into dx. Now in the second case we are going to do it with x into dy, because the length of the horizontal strip is nothing but x and the breadth of the horizontal strip is dy. So what will be the area of the horizontal strip? Area of the horizontal strip will be area of the strip. Area of the strip. Area of the strip will be x into dy, will be x into dy. Right, now I'm going to, this is point A and the coordinate of A will be a comma 0. Similarly the coordinate of B point will be 0 comma B. So now what I'm going to do is that I'm interested to find the area of this portion OABO. So area of OABO is nothing but integral which tends from 0 to B. I'm going to set the limit from 0 to B. In the previous case I set the limit from 0 to A. Instead of 0 to A, now I am using it from 0 to B. Why? Because I am using the horizontal strip over here. That is the reason. So I am fixing the limit from 0 to B. It is from 0 to B, right? It is from 0 to B and x into dy. It will be x into dy, right? The area of OABO will be integral tends from 0 to B x into dy. So now what I'm going to do is that I want to find the value of x. So for finding the value of x, I'm going to use the area of the ellipse. I mean the equation of the ellipse. So the equation of the ellipse is x squared divided by a squared plus y squared divided by b squared equal to 1. So I am interested to find the value of x. So from this equation I can derive the value of x. So the value of x will be x squared divided by a squared, which is equal to 1 minus of y squared divided by b squared. So I am simplifying this term. If I simplify, I get b squared minus y squared. So this part is x squared divided by a squared. So x squared is nothing but a squared divided by b squared into b squared minus y squared. So what will be my x value? X value, here I am writing it. My x value is nothing but plus or minus root of a squared divided by b squared into b squared minus y squared. This is my x value. So what I'm going to do is I'm going to take this a squared by b squared out of the root. If I take it out of the root, it will be a by b. Another thing is that I've been left with the two signs, positive and negative, since in the first quadrant all the values, all the quantities which I am deriving, it's going to be positive. So I am taking only the positive value. So it will be positive root of, it will be a by b root of b squared minus y squared. So this will be the value of x, that is a by b into root of b squared minus y squared. And once I get this value of x, I am going to substitute it with the integral quantity. Integral quantity is the area OABO. So I got the value of x over here, right? So now in my integration tends from 0 to b. This x value is a divided by b into root of b squared minus y squared, b squared minus y squared into dy, right? So I got this 0 to b. My integral tends from 0 to b, that is a by b root of b squared minus y squared into dy. So I have substituted in this expression. So now I have another formula. What I'm going to do is integral of root of a squared minus x squared into dx is nothing but x divided by 2 into root of a squared minus x squared plus a squared divided by 2 into sine inverse of x divided by a plus c. This is the general formula. Now what I'm going to do is, instead of a, I'm going to substitute it with b, and instead of x, I'm going to substitute it with y. So if I do it, I'll be able to get this expression, and from this I'll be able to get the area of the first quadrant, and from the first quadrant, if I multiply, I'll be able to get the total area that has been bounded by the ellipse, right? So now what I'm going to do is integral of root of b squared minus y squared, into dy. So that will be nothing but, instead of x, I need to substitute with y. So it will be y divided by 2 into root of a squared minus, see, this is b squared minus y squared into dy. A squared minus y squared plus, for a I'm going to substitute with b, it will be b squared divided by 2 sine inverse of, instead of x I'm going to substitute it with y divided by a plus c. This is the expression I had found from this general formula, and now I'm going to take this expression and I'm going to include in this integral, main part of the integral. So I'm erasing the first portion. So it will be this a by b, I am putting it outside, a by b into y divided by 2 into root of a squared minus y into root of mm, into root of b squared minus y squared into root of b squared minus y squared plus a squared. Instead of a, I'm going to substitute it as b squared divided by 2 into sine inverse of x, sine inverse of y divided by a plus c, and I'm going to fix the limits at 0 to b. So it will be y by 2 into root of b squared minus x squared minus y squared plus b squared divided by 2 into sine inverse of y by a plus c. So now I am erasing this portion. It will be from 0. So now it will be a divided by b. I am going to substitute y in terms of b. I am going to substitute y in terms of b. So this will y by b. This instead of a it will be b. Instead of a it will be b. Right? So now all the terms are arranged with b's and y's. So we also have b and y over here. So what I'm going to do is, now I'm going to substitute b in terms of y. If I do it, it will be b by 2 into root of b squared minus b squared plus b squared divided by 2 into sine inverse of b by b. This is for b. Now what I'm going to do is that I'm going to substitute 0 in terms, do it, it will be 0 by 2 will be infinity. Similarly for sine inverse of y by b, if I substitute 0 in place of y, it will be 0 by b, which is nothing but, again it is going to be infinity. So the total expression, the second expression will turn out to be null and void. So I'm not going to use the second expression. So now what I'm going to do is that I'm going to use this expression. This expression will be a divided by b into, see in this one, b squared minus b squared, which is 0, so it will be null and void. So I'll be left out only with this one, which is nothing but b squared divided by 2 into sine inverse of b by b is sine inverse of 1, sine inverse of 1, which is nothing but pi by 2 into pi divided by 2. So what will happen? B will get cancelled. So I'm writing it over here. So the left out values will be AB pi divided by 2 twos are 4. So it will be 4, which is nothing but pi into AB divided by 4. So this is the value for the first quadrant. The area enclosed by the ellipse in the first quadrant is pi AB by 4. So in this ellipse, ellipse is divided into 4 quadrants. So since it is divided into 4 quadrants, what I'm going to do is that I'm going to multiply by 4. If I multiply by 4, 4 gets cancelled. So my resultant value will be pi AB. Pi AB. Okay. This value is same as this value, the value which we had found in case number 1. This is case number 2. So both case 1 and case 2 are identical. They are equal. So what will happen means, even though I use a vertical strip or a horizontal strip, it doesn't matter. The value will be same, right? For both the things, the value is same, right? So the result is pi AB, right? Thank you guys. Please do subscribe my channel for more interesting and upcoming videos.